All right. The second technique we are going to learn, all right? The second technique that we want to learn is converting galvanometer to be used as a voltmeter in our laboratory. Okay, so we have the circuit is as simple as you can have it. Here, you connect a multiplier in series with the galvanometer, right? So this is quite different from the case of galvanometer to ammeter, because that was a case of parallel connection, but this case is a case of series connection. When we connect a multiplier in series with the galvanometer, if you begin to take the reading from galvanometer, that reading is in voltage or in volts. Now, what is a multiplier? A multiplier is a resistor of very high resistance. So when we connect that in series with the galvanometer, the result is going to produce a voltmeter. Now, because there is no branch in the circuit, the current that enters galvanometer G is the current that will also pass and enter into the multiplier, and is the same current that will be coming out. Excuse me. So we want to write the expression for the current. The total current that is incoming is equal to the current that will enter galvanometer, and it is also the current that will come out in the multiplier. So this is simply our equation 1. Very simple to arrive at. Right? So the second equation we're going to look at is the potential difference across the terminals of these two devices. So the PD across G plus the PD across the multiplier, all right, is equal to the total voltage, or is equal to the total PD. So if our total PD is V subscript T, then we have PD across the G, then we have PD across the multiplier. So the equation is simply like this. You can call this one our equation 2, right? So again, using Ohm's law, we know that potential difference is equal to current times resistance, okay? And for that reason, if we use the same common idea from equation 2, so we now say from equation 2, all right, total potential difference will be equal to current times total resistance, all right? And the result is equal to, we have the same current of galvanometer times resistance of galvanometer, and then plus the current of multiplier times the resistance of multiplier. But we do know that our I is equal to Ig, which is equal to Im. So we could write the equation as current times total resistance is equal to the same current times resistance of galvanometer plus current times resistance of multiplier. So our current times total resistance is equal to current into resistance of galvanometer plus resistance of multiplier. Now, when we have an equation like this current will take out that current. And we now say, therefore, the total resistance is equal to resistance of galvanometer plus resistance of the multiplier. So this equation for us is equation 3. So at this level, we can write 3 different equations. This is 1, 2, and then 3. All right, these 3 equations will help us to be able to convert a galvanometer to a voltmeter in the laboratory. Now, if you come across this video, I want you to have this video, want you to subscribe to our channels, I want you to also give us a thumb up as well as share the video so that others can see and then have a benefit of what we are doing here. Thank you.